Hello, friends. Let me actually minimize my audio panel now. Alrighty. So, I think the serialization one just popped in because I don't think that was on the radar before. Actually, let me now check open what we have in Outlook. Yeah, we started with the concurrent dictionary thingy here. So, I think, Eric, that's yours, right? Yeah.
Yeah, that's mine. Yeah, so this is a pretty straightforward request. It's basically exposing a compare property in concurrent dictionary in line with the other hash table implementations that we have in collections. That's it, more or less. It would be a non-nullable property also. So if in line again with dictionary, it would return a quality compare.default if none was specified by the user.
Seems fine to me.
I'm thinking. Is that the first concurrent one that actually has the compare exposed?
Sorry, could you repeat that question, Nemo?
Is that the first concurrent collection that has the property exposed?
I do not know the answer to that.
Do any other concurrent things take a comparer?
That's a good question.
It doesn't seem like it.
Because it's queue, stack, collection, bag. Like none of these seem like they would have a comparer.
Yeah, it's only concurrent dictionary, really.
Yeah. Yep, seems fine.
I'm just being redundantly paranoid and making sure it's the same thing we called it on non-concurrent dictionary. Yep, like character for character copy. So, thumbs up from me. Any dissent?
Nope, looks good to me.
All right. Easy ones always make this meeting feel productive.
Indeed. Let me check the other ones. I feel like no, it is. Yeah, there's one more for Eric. Align API surfaces. That would be this one here.
Yep. So this,
there goes the meeting.
There goes the meeting. So this basically follows a series of other API proposals that basically introduce parity between the immutable builder types and the actual immutable types. We generally, in principle, we do ensure that there is parity. So this is basically just adding everything that is missing in this case. So this was compiled by the user. I've also kind of decided that removing certain methods that didn't make any sense in the context of a mutable builder type. But this would more or less make sure that there is a one-to-one parity between the mutable collections and their corresponding builder types.
So just as a question here, I do think that the general API is fine, but Roslyn has occasional pain points with updating to new system collections immutable due to how it works between here and VS. Do we know if there's going to be any concerns from them from extending this to include these new types?
That I do not know personally. What types of issues are you referring to?
Exactly. VS depends on a particular version of system collections immutable. Roslyn depends on one, and they need to stay in sync.
Right. So these are forks, presumably, of that library, right?
No. They just use system collections immutable. It might just be worth a small sync up with Jared to find out who's responsible for that, since it's not Andy anymore, and make sure that they're not going to be broken at all by, or at least that they're aware that there's going to be changes here.
So I'm not entirely sure I follow. What's the concern?
Every time we've revved system collections immutable in the past, it's caused pain points for Roslyn because of having to coordinate between what they're using in one of their targets versus what exists in VS.
Right, but like, I mean, the fix seems to be them not updating that dependency then, right?
Right, but
yeah, they don't have to use the new API.
That's somewhat automatic when they go start multi-targeting the latest .NET version.
I mean,
yeah,
if Roslyn and VS have a problem with us adding to a package, they need to work that out. We aren't freezing packages just because someone has a problem with versioning.
Right. I'm not saying that we should freeze the version. I'm saying that we should make sure that they're at least aware that we're making changes and see if there needs to be any coordination with them to make it easy. There's some things that I just can't say because we're live streaming.
Fair enough.
I can provide more details offline.
Yeah, we can follow up offline. I think. I think in general, I mean, like they are on the distribution list of the designs, right? So they will get an email like everybody else that we add these APIs. But it seems to me the general gist is, don't update the VS copy, don't update the thing that they depend on. So seems reasonable in general. But yeah, I don't think it's acceptable for us to not add APIs because of that. So, I mean, it will boil down to them giving them a heads up and saying this is coming.
I would also say that this is a kind of from my perspective, a low priority API proposal. So it's not even clear to me that we would be committing to implementing this for 6 even, hence the milestone. So perhaps this is a type of concern to address at the point where we actually decide to include this. Does that make sense? So would it make sense to agree whether we want to introduce these APIs in principle and then proceed with notifying the teams when we actually do implement those?
Yeah, so like I was just rearranging the C# code here to make it look like C#. Like basically my understanding is that all these types already exist, right? You're just proposing to add new members to them, correct?
Correct.
I mean, I think in general it makes sense. I mean, I'm just looking over each of the methods. I mean, they all seem to make sense largely.
For what it's worth, there's another addition in one of the linked issues that has also been approved but not implemented yet. So I'm assuming that the exact same concerns also apply to that addition.
Right. I mean, did you look at the extensions at all? Because immutable array has a bunch of stuff that lives on the extension type. I assume none of them are there. I think they were mostly link related. Yeah, looking at it, it's just all link stuff, so it's fine. So the only one that's a bit weird is the add range that takes an array, that takes an immutable array. Why does it only take int length? It probably
Sorry,
should
which
take
one are you referring to?
the fourth. Add range immutable array items, comma int length. It seems if you want to add this one, I would probably go with all three, meaning the items, the offset, and the length. And then same for the t-derived one. I will probably do the same thing, because I mean, it seems odd that, you can generally add an immutable array selecting a length, but then you can't select an offset, and you can also not do it if it's a derived type. It seems somewhat odd.
Yeah, I guess the spirit of the proposal is to just I guess incorporate what exists in the other type without innovating in that space, because there were other opportunities as well in other methods, and we kind of decided that would be the subject of a different API proposal.
I see now. Well, interesting. Okay, so it literally is just what's on the builder today.
Yeah.
Which, yeah, okay, so that's not great then. Yeah, I mean, I buy that. Like, if it's literally just doing that, then I think it's also easier to review.
Yeah, I mean, for example, there were certain methods where, with the offsets, like you mentioned, where, you could consider, taking a span argument, but, in that case, why not add it to the original method as well? And, lo and behold, it becomes a completely orthogonal concern.
Do we generally have like unit tests for stuff like that, where we say, keep surface area A consistent surface area B? Is this usually a thing we do?
Sorry, could you repeat that?
Do we sometimes have unit tests that basically validate that surface area A is replicated in type B?
Not to my knowledge.
I mean, we do have it in some places. I just don't think we have one here, but maybe we want one.
Would it be worthwhile just having a internal interface? Like we've got iSpan formatable, which is internal, and we've got that on various types. We could theoretically have an internal immutable array methods that both builder and the non-builder type implement, and then that would ensure that they stay in sync. And since it's internal, we don't have to worry about versioning, really. Particularly if it's never actually used.
Yeah, I think the reason I'm bringing this up is because we recently discussed this for enumerable and iterable, right? So it seems like that will be also an area where we want to make sure that as we're adding new items, we do it consistently. So yeah, interface also works for me.
Yeah, and math and mathf are also kind of similar, where every double method we expose on one, we want the single equivalent on the other.
Yeah, so this proposal, Eric, is just taking all of the data e-members off of the builder and the parent type and just making sure that there's that the same method appears in both places. And so you're adding all the ones that are missing.
Correct.
So nothing here is really a think about it item. They got out of sync and we're just resynchronizing them.
Correct. There were certain methods residing in the immutable collections that were not included in the builder for reasons that it didn't really make sense to incorporate in something that is mutable fundamentally. So they have been sort of removed completely.
Okay.
All right.
I don't think I have any feedback.
Yeah, looks fine to me as proposed.
The author of the proposal is on YouTube, and they mentioned that it looks like Immutable Array Builder has a reverse method that's not being proposed as mirrored on Immutable Array here because it would hide the link method, and therefore it would potentially be a source breaking change for some users.
Yeah, that's correct. We also removed the reverse one for that reason.
Would that actually be a source breaking change since Immutable Array implements IEnumerable and therefore
it does.
And so therefore it would still implicitly convert. It would just end up doing so by boxing, which it would already be doing if you called the link method.
It would copy its contents. I believe that it would copy its contents into a new immutable array instance.
Right, which is already how the link version works, correct?
I mean, not eagerly. You would get an IEnumerable that would presumably perform optimizations depending on the source enumerable.
I mean, it's a source breaking change because you get back a different type, right? The one produces an immutable array, the other one produces an IEnumerable, right? So depending on what you do next, might no longer compile.
But immutable array is implicitly convertible to IEnumerable, and implements IEnumerable. So you just potentially have a performance regression, but you shouldn't actually break source.
I mean, you can totally construct cases where you do, right? Where, let's say you pass it to a method that is overloaded between IEnumerable and immutable array, and now you're calling the other one, right? I mean, I agree with you that it's probably not a biggie, and honestly, like, source breaking changes like this seems like something I would be willing to do, but it's probably also fair to say that it's not a, drop-in replacement that just every code will always compile. I mean, I would generally say, like, I think it's okay for us to add method surface area to a type that happens to implement IEnumerable, and then just say, like, yep, sorry, we made the type more efficient, so sorry, you may have to adjust your code. Because I think it's just not feasible for us to track that in general. Like, there's too many things that are extension methods of IEnumerable, and like way too much stuff implements IEnumerable, right?
I don't really see where the source break would come on this one, because I think the only concrete type we bring back from reverse is IEnumerable. So that's the only thing you could. So that's the static type declared as the return, and I don't think the type it returns is even public. So the only thing that you could be doing from the current call is putting it in an IEnumerable, and since the type we would return implements IEnumerable, it would be assignable. You would then get the problem that if you started depending on the new method and then like cross-compiled, you'd get a I can't convert this error, which would confuse you, but it wouldn't be breaking for anyone going forward. It's a recompile behavioral difference of maybe performance impact, but it's not a, you wouldn't get any failure. I can't see where a failure would come in. So
what I'm hearing is that the breaking change is either not there or we're okay with it.
Yeah, but like I don't see this one as a break. I think if it was going to introduce a compile break, that we would say no. But I'm pretty sure enumerable.reverse returns IEnumerable, and in the type, the concrete type it's returning is not a public type, so you couldn't be casting that away anyway.
For what it's worth, I checked the link reverse implementation, and it's also just copying the source into a buffer, which surprises me. So fundamentally, you wouldn't see a big difference in what actually happens.
So is this the only one we've removed? So there's like a reverse. What are the other ones?
That was the only one that was removed out of concerns for, just, link. I guess using that method shadowing the link equivalent. The other ones were removed primarily for reasons that they just weren't a good fit for a mutable type. So if you scroll up, there is an enumeration of those in the conversation, if you'd like to go through them.
Sorry, are you saying that there's a link I should click? Is that what you said?
Sorry, could you repeat that?
Sorry, is there a discussion on YouTube, or is there a link I should click? Or what is the...
in the thread of the issue, there's a conversation about the methods that were removed. So, for example,
I think it's the one you just scrolled past, demo.
Yeah. So probably this one here, right?
I think it's further down. Let me.
I mean, honestly, like, I'm okay with leaving it as is and just approving this as is, and then basically saying whoever does the work, the first thing you should do is, do the whatever we do, either the interface or the testing, and then just see what actually is complained about, and then have a conversation on those things, and then just decide whether we either convince ourselves the breaking change isn't there, or we just convince ourselves that it's acceptable, or decide to not do them. But it seems like that should be something that we should probably do. I mean, there's also some discussion on just removing things that we think are not strictly necessary, which seems a little bit odd, because if we want to say we just, align the surface area, it seems easier to just do that rather than pick and choose.
I guess the motivation behind adding the APIs listed in the issue, in the final form of the issue, is that there are ergonomic concerns in the sense that you can use one builder to make a whole sort of mutable operations before you recreate the immutable instance. Now, the methods that I recommended removing, you could actually achieve the exact same result with the mutable builder. So if you scroll down a bit, there's a method in immutable sorted dictionary called setItems, where you basically set a sequence of key value pairs. Now, that would be a very unusual method to expose in a mutable dictionary because you would just use a for each with an indexer.
Right.
So my argument is that, we could say that, hey, we just need to have 100% parity between the two types, or we can say that, because they're fundamentally different, you can essentially achieve the exact same goal with the standard access patterns of, mutable dictionaries.
Yeah, I think this goes back to like what's our motivation to aligning them, right? If the motivation is you want to make it, relatively pain-free from people go from an immutable to a builder, because let's say they do a bunch of stuff, right, and then they just do two builder for the variable, and then they just do the one thing that they want to do differently with the builder because it's more efficient, then it seems reasonable for me to have parity, because it's just less things you have to patch up, right? You basically lower the bar for people to go from the build, to the builder. I think I could probably live with the reverse, meaning I think it's okay to say when you go from a builder to immutable, you lose some expressiveness. So in that sense, I think the builder should probably be a superset, if anything, because we don't want to have people like to necessarily say, oh, I go away from the builder because that's easier, because then you have less efficient code, right?
Sure. I guess if we were to stretch that logic to its logical conclusion, I could additionally argue that, the API signatures should match as well. So, for example, if we're looking at that specific setItems method, in the mutable version, it actually returns, the return type is immutable sorted dictionary rather than void. So one would argue that why wouldn't we also make setItems return builder to have the sort of fluent-like way of doing updates to the builder type? I mean, if we feel that this is the way, then let's do it that way, so that you can just copy and paste and change the type and it still compiles, right?
Well, the problem with doing that is that that's just an API breaking change, right? We can't change return types for existing methods. So anything that returns void today will have to return void in the future.
Yeah.
But yeah, I mean, that's a good point. Like on the immutable type, you always have to use the return type, otherwise you just didn't do anything. So that means every time you go from an immutable one to a mutable one, the code will probably not compile no matter what. In which case, if we are back to picking and choosing anyway. So then maybe just leave it as what we have today, and then it also seems at that point whatever unit tests we have would be more complicated because we couldn't do it with an interface because the signatures would differ, right?
Right.
Yeah, then let's do that. All right, so then let's just leave it as this then, and then, I don't know. I'm okay with just approving it as is, and then just say, somebody should sit down to the test, and then if the test has any fallout, then bring whatever the fallout is for discussion, right?
Mm-hmm. I guess I have one final question. I mean, how do people feel about, potentially doing this for 6?
I mean, it's pretty early for 6. I would be okay with taking this for 6 if somebody's doing the work. I'm not sure we want to fund it, but if somebody in the community submits it seems reasonable for me to take.
Okay, so good candidate up for grabs then. Okay.
Yeah, I mean, it seems a pretty straightforward implementation, right? All the code already exists. It's just shoveling some code between A and B and add some test coverage for this. It's not hard. It's just busy work. I think the only hard part here would be the test, probably.
Cool.
All right, so that was easy. At least easier than I expected it to be. And I think all the other ones are now analyzers, I believe. Yes, so parcel number. So I think we start with this guy here, right? And then the rest is just depending on how far we get. All right, Carlos.
All right, so this analyzer, the idea is that it detects the underlying data type of source and destination when calling block copy. If they are not byte array type, then we cannot use the length property for the count argument because it wouldn't be in bytes. So it might be easier to understand if we just scroll down to the example. So the cases where we would warn are those where the underlying data type of source and destination is not a byte. And if we use destination length, whether we pass it directly or we save it in another variable, we would warn. We wouldn't warn if the user is passing another property or or an integer, or even if they call a method, because the assumption is that the user knows that they are calculating the bytes for that data type. Does that make sense so far?
But because buffer block copy is, so it's the thing it wants to copy is the number of bytes, right?
Yeah.
So if you have a thing that's more than 1 byte, you're just going to fail because it's not big enough.
Right.
So this is really like, I mean, we can do the analyzer, but really everyone should just figure this out immediately when you hit the line of code, unless we're saying that we want the suggested, you wrote the line of code and we squiggle it and we say you probably mean divided by size of thingy, but you probably can't use size of because you're probably not in unsafe code.
Right. And well, we
because I guess my question is: are we talking about an analyzer? Or are we talking about a fixer, which
no fixer? For this case, we decided that maybe a fixer wouldn't be appropriate. Only the analyzer, and let the user choose how to manually.
So basically, you would only flag when the argument for bytes is coming from an array length. Is that basically the heuristic you're going for?
And if the underlying data type is not byte. So if you keep scrolling down, you can see other examples where we wouldn't warn.
I see.
If we use byte or s byte, then using length is okay.
I mean, that seems reasonable, right? Because it's a very simple heuristic, and we know that pretty much 100% of the time, if you're doing array.length, you're doing it wrong.
To Jeremy's point, we're basically taking something that will throw at runtime and making it a warning at compile time.
Right.
Yeah, it seems to me that's a waste of processing power. Hit the line of code, it crashes, you fix it. Like, unless we're proposing a fixer to go along with it, I don't think this has value.
Okay.
That's a strong statement. I mean, I don't know, like in general, I prefer like design time errors at design time rather than having to run my tests for that. But I mean, I hear what you're saying, like it would never work, or like, you know, any example that would work would be fairly contrived. So, but it's possible that you're looking at the result and you will be very confused why it doesn't work, right? Versus if you actually get it squiggly.
Yeah, I suppose, I guess my question is, what's the value that the analyzer is adding? If it's that we're adding a very helpful, hey, this works in the number of bytes and you're passing an array.length, this probably isn't what you want, as opposed to the exception message, which is length too large, and you're like, I passed length, it can't be too large, then I guess that would be where the value comes in. But if it's just, hey, this isn't going to work, it turns out the runtime will tell you that too.
I mean, in most cases, it would not be too large, right? In most cases, it would be too small, right? So that means you probably don't get an exception, you just get a partially filled array.
So what's the actual?
Oh yeah.
What's the actual use case for this API over using array.copy, which is simpler, just as efficient because it also uses the inefficient block copy under the covers, and doesn't deal with bytes, deals with elements?
I mean, that's a fair question. I mean, the answer is usually, you know, however people found this line of code, right? They stumbled over the type, or they copied it from somebody else, or they heard somebody else saying block copy is more efficient than array.copy or something like that, right?
Because it seems like block copy, like, for all intents and purposes, this is an unsafe API because it deals not with the type of the array, but with bytes instead. It's not constrained to a T, but it's going to throw if the type is not a primitive type, at least looking at the implementation here. So all in all, it just seems like it's a vastly inferior mechanism over using array.copy or unsafe.copy, which is explicitly unsafe and makes the usage of byte very clear.
I mean, I honestly forgot. Like, I mean, presumably we added block copy for a reason, right?
We also, if you just look at source.net, there are almost 500 uses of it. So the question is, if that were true, why?
I mean, I would guess that the reason why it exists is, and Levi's not here, but he's probably the best person to remember. I would guess, though, it was added before we added the equivalent unsafe API, and potentially before we had optimized array.copy itself to use buffer mem move.
I mean, block copy
so
is one of the
might
oldest
just be a
APIs we have,
thing.
so that would be in support of what Tanner just said. It exists since on Framework 1.0, whereas the other ones are all, of course, much newer.
So if that's the case, it might be that maybe we shouldn't have this analyzer, but instead we should have one that says, don't use this API, go use array copy, or unsafe instead, to make what you're doing very clear, and just because they're better and more type safe APIs.
I mean, on the one hand side, yes. On the other hand, it seems like a fairly big hammer, because basically what you're doing is you're obsoleting the API with an analyzer, right?
Yeah.
And given that the API exists since .NET Framework 1.0, I mean, we may only have 500 usages in our code base, but I'm inclined to believe that the usage is much bigger outside of our realm. So
right,
it would be something that probably wouldn't be sustainable as an obsolete, would be my guess. Because it's not that the API is wrong, right? If your code works today, it's fine. It's just,
right.
You're probably holding it wrong likely for the first time when you're using the API.
Right. So I wasn't suggesting like put the obsolete attribute on it, but this is more akin to like, this isn't recommended for future use because we have better alternatives in modern code.
We could suggest both things. Detect that the argument passed to count is probably not the correct one, and say make sure to pass the number of bytes, or use these other alternatives. We could have that message, include both suggestions.
I mean, that's not a bad idea. I mean, I actually like the idea that we keyed off of, your code is wrong, which is an indicator that you're not knowing what you're doing. So probably you want to use array.copy instead, right? Which is probably more helpful than flagging code that actually does work because you wrote it 5 years ago and tested it. And so that seems a bit more scoped in nature than effectively obsoleting block copy, right? Because I mean, even if you don't use obsolete, even if you make it in, opt-in analyzer or something, first of all, people won't do it, right? They will not opt into this, so you will get very few usage of that. And honestly, if we just add a warning that is scoped enough that we believe we can have it on by default, I probably would prefer that, because that you basically avoid the bleeding here, as in you avoid more people taking dependency on an API that is hard to use. Is the silence agreeing, or is the silence I'm trying to figure out how I can express my dissent?
Can you state it again so I can reprocess?
Like I said, to me, so what Tanner is effectively suggesting is basically we flag the API either by making it obsolete or having an analyzer that is opt-in that says don't use buffer.block copy, use something else, right? And I actually like the suggestions from Carlos to say we don't do that. Instead, we just basically flagging code that we know is wrong, meaning what the analyzer is supposedly doing here, and then just change the message to say, by the way, you probably want to use array.copy anyways.
I mean, if we're flagging the specific pattern that is, source 0, def 0, source.length, there's no reason it couldn't have a fixer that offered both options of fixing the length or switching to use array copy.
Yeah, I agree with that too.
Yeah. And someone had pointed out earlier that where I thought that the right answer is you needed to divide the length by the size is you need to multiply. Therefore, there isn't an exception. You just get a truncated copy. So
right,
I retract the analyzer has no value. But yeah, I think that I don't think that there's a problem with people who call buffer.block copy because it's in my fingers of when I need to copy one byte array into another because it was faster in .NET 2 framework. I'm old. So as long as you're using it with bytes, it's fine and what it was designed for. And it used to be the case that array.copy doing its type switches would call buffer.blockCopy if you were doing bytes. So suggesting that someone change it on, depending on what frameworks they all care about with their code sample, that would be a worse answer. But saying, hey, this isn't bytes, you probably meant array.copy, totally seems like a fine suggestion from a fixer. Or multiplying by the runtime version of get the value size. It can propose both.
Yeah, okay, so are we okay with this being on by default as warning?
Yeah, given that you get less data than you probably meant, as opposed to an exception, I now agree that it makes sense we see that you did from source 0, comma, stuff, source.length. I don't think it matters that it was going to dest 0. And that, hey, this probably is not what you wanted.
Yeah, I mean, I can't think of a case where if you do what the analyzer flags would be intentional or desirable. And so in that case, I think it will not have any false positives.
Yeah. I mean, somebody bizarrely could want only the first quarter of a integer array to be copied, but they can then, I don't know, suppress or multiply by 1.
I mean, the only cases where I can think of this being the case would be, a magic header or something, but in this case, you would have a literal, right? You would now, I want exactly 16 bytes or something. It seems weird to me to use the array length to make the determination that you want that particular subset of the array. Seems that way. All right, so then, given that there's no dissent of what we just said, let me approve this and copy in my notes.
Cool, thank you. We could also consider expanding the documentation for this API in case we are not mentioning that potential problem. But yeah, that's separate. Okay, so
I think this one is also yours, right?
Can you repeat that again?
I think this is also yours, right?
Yeah.
33778.
So the idea here is to suggest using the ask method instead of substring. If we are passing the result as an argument to a method that has an overload that takes both string or span. So always up or using the span overload. And I have a few examples there. So depending on the number of arguments it has, the substring is the overload of ask span that we would substitute. I'm also making sure to consider the cases where the arguments are passed named because we need to make sure to change the name of the argument to the correct one because the names could be different. And if you just scroll down, you can see the different overloads that exist for the hypothetical my method.
So do we already have a similar one for array? I believe we do, right? It's just that on array, I think it's slightly different, where if you assign the slicing to a span, we suggest that you add as span before you do the slicing, right?
Yeah, I think so. If that comes from, I can check real quick.
So, and I think this one is also info and in the performance category, so it seems like makes sense what you're proposing here to me. Oops.
Any dissent?
We also have string.asMemory, which makes a read-only memory of char, right? If so, my suggestion is we do as memory at the same time, and in the event that there's a triple overload group of string read-only span and read-only memory, I think it should go to span, probably.
Yeah, I mean, I don't think there's a problem with being complete. At the same time, I would be surprised if the memory support added a huge amount of, if it detected a bunch of additional cases. The vast majority of APIs that we've exposed, at least, are string and span rather than string and memory or string and span and memory.
Yeah, the only time that I can really think of when it would pop up from memory is if it was a T and it picked T being char. Because I agree that I can't think of places where we would take a read-only memory of char and expect that it's a string, except for the trim APIs.
I see.
But I feel like those were instant extension methods over read-only span or read-only memory of char, so I don't think that anyone, they'd have to call it statically and then pass in a substring for it to apply. So it may not have many hits. It just kind of feels like once we're already in there doing the work, that making it work for both span and memory is beneficial, and in the event of a tie, pick span. But if we think it's work for no actual practical value, then that's fine too. It's just a suggestion.
Maybe we can just take a conservative path of just doing it for span right now, and if someone suggests or requests adding the memory one, we could expand this analyzer and fixer. We can just keep the note that this could be a potential expansion for the fixer.
Yeah, it's fine.
This would not fire in the case where the target type of s.substring is IEnumerable, correct? Since you can't box span?
I think this is only for when you have a string. Basically, the data type is string.
Right. The source type, the S, is a string. But if you're passing it to my method and the parameter that the corresponding parameter to that is IEnumerable.
I think we're only doing it where the destination type is string, not IEnumerable of char, not object, not anything else.
Well, where there's either the destination type is read-only span of char, or there's an overload that has a read-only span of char.
Okay.
Sorry, but what I was saying was, I think we'd only do this in the case where the existing method that's called is accepting a string, is typed as string. Then, when you find such a case, we look to see if there's an overload that takes a read-only span of char instead.
Right. Well, I mean, it could already be being passed as s.substring to a method that takes a read-only span of char and has no string overload. And if we're not already finding that, we should.
Right. I think there was a separate issue for that, wasn't there? Maybe I'm wrong. Maybe not.
I don't remember if that's the one I did or not.
But yes, if you were passing, if you were already passing a string to something that took a read-only span, a substring to something that took a read-only span of char, then yeah, we'd want to warn on that as well, whether it's this analyzer or another one, or info on that, I should say.
Yeah. So sounds like, or it seems fine to me, given my understanding of what it's doing. If we feel like doing read-only memory, great, and if we don't, that's fine. I agree. I can't think of a place where it would come up unless it's in a generic method where char ends up being the resolved type to make it compile. But that may require too many inference steps. So, I mean, I guess you could explicitly say foo of char, but probably doesn't have enough value.
All right, so like I think I understood everything that was said, and the conclusion was that we just keep this analyzer as is, not generalizing it, and the severity info is also fine.
Perfect.
Okay. All right, then sequence equals.
Okay. So the idea of this analyzer is to find cases where we are iterating through two arrays and comparing elements in the array, and instead suggest using sequence equal.
How are we planning on finding those things?
I have a few examples down there. If you can scroll down, Emo.
I mean, this from the title, it sounds reasonable. I just wonder, are there enough cases that we can detect that it's useful?
So in particular for this, we cannot use this for float or double because sequence equal does not use operator equals. It uses dot equals, which has different behavior.
Okay, so we can constrain it to those would be the two exceptions, or can you think of any others?
It would be,
right?
You would have to accept anything that has either an explicit or implicit operator equals, not equals.
Oh, okay.
I kind of wonder, I can't remember if I proposed this or if Levi proposed this or someone else proposed this, but I'm not sure it's really worth it. It's going to be a pretty complex, which should read as expensive rule, I think, because the for loops show up everywhere. We'd have to analyze, at least look at every single one. Some of them, from a performance perspective, are probably actually losses, since there is some fixed startup overhead to sequence equals. In fact, I think in our own code, there are some places where we explicitly don't do sequence equals because we expect them to be 2 or 3 elements or something. And it saves you at best, 3 lines of code instead of 1 line of code. So I don't know that it's worth it.
It's definitely a perf win for large arrays.
Oh, absolutely. Large arrays of primitive, ints, bytes, that sort of thing, it's absolutely a win.
But when it comes to arbitrary types and special cases like float, half, double, some of the vector types, etc., it becomes a potential change in behavior, which may be undesirable.
Well, I mean, it'd be a potential change in behavior for anything that had an operator, right?
Right. Although most things tend to have them be the same.
The sequence equals actually, it doesn't use equals, does it? Does it just split? Does it require the type to be splittable?
It looks like it goes down two different paths.
Okay.
Yeah, because it if it's splittable, it ends up going down a vectorized path, which will just do a bitwise integer comparison.
And if it's not splittable, it does dot equals?
I'm trying to find where it does or filters that.
Or a quality compare of t dot compare or dot default or something?
That's what I'm trying to find. Yeah, it does. It just does dot equals. Over an I, because it constrains it to I equatable of t there in that case.
So there are a few constraints for this analyzer. One is we're iterating through the whole data, not just a few of them. So that would be one of the triggers for the analyzer to show up. The other one is what was mentioned in the last comment in the thread. It seems that sequence equal can detect if the length of both arrays is the same. So whether we do that comparison before or not could also be another condition to propose using sequence equal, because sequence equal does the same comparison, right? And the other constraint is what Tanner mentioned, that there are some data types should not trigger this.
So just a moment, Carlos.
Yeah.
Is there anyone who's currently in favor of having this?
I think it'd be fine as like a low priority one that can help flag potential performance optimizations. But as with many performance optimizations, I think users need some additional annotations on keep in mind that this may break for these types of scenarios, and it may regress performance for small arrays or other things.
I mean, to that point, if we were to do it, I think it wouldn't even be info. It would be like, this helpful thing you could turn on while you were doing your development to see if there was anything interesting, and then you turn it back off.
Yeah, because I think that the performance hit of running this, which is going to be a very complex state builder, the performance hit of running this is going to be worse than, like, it. I think it's negative value to the universe, not to like the one person who it helps. So I don't think it's a thing that we should waste our time on. Is my feeling. Like, it'll either not catch a bunch of things and we're going to keep special casing, like, oh, there's this other kind of pattern that kind of looks like the thing that we kind of wanted it to find. And then, oh, now let's go exclude anything that has an equal, and exclude anything that's a generic method because we don't know if it's an equal, or if it's going to end up having equal match. I don't actually remember how equal works with generics, but like, I think that we're going to end up just special casing it back and forth, and we're going to want it off by default, and I think we just shouldn't even do it.
I mean, also, how often do we think people do open-coded comparisons? Is that common code to write, or would most people just use some other API to do the same thing? Because if that's the case, then I think it will be easier to just scope the analyzer to look for some other method call rather than trying to detect everything that you do in for loops.
Yeah, but I think if you're calling some other method, then that other method's probably fine.
Yeah, that's the question, right? So like if we believe that's the case, then we are now down to the last mile, right? Where I'm not even sure the thing that Steven suggested is, worthwhile building either.
I think the only other method I'm aware of that's sort of in the same ballpark is enumerable.sequence equal. So, you could say if you're calling enumerable.sequence equal with two arrays, don't do that. But meh.
Yeah, I guess. If it looks like you're doing enumerable.sequence equal with two things that are convertible to span, then it's just like the substring thing. If we have a better answer with span.
Right.
Especially because if we can prove that you have, two arrays, then it can avoid any enumerable runtime sniffing of, can I do something smart here? And you just go straight to the thing that would actually do the work. But that's all that I think we would do on this. I don't think it's worthwhile to do the pattern matching on code.
So you would be looking for what? You would basically look whether you have two arrays and you call equals on them, or what are you looking for?
Any call to enumerable.sequence equal where the two arguments are both arrays.
I see.
And that it would be, hey, if you take the left argument and do .as_span first, then now you get span sequence equal, which is better.
Is there any reason why we can't just add an instance method on SD arrays that is sequence equal that does that? That seems like would just automatically fix it for everybody.
Or we add a special code path to enumerable sequence equal that just, does a type check.
Well, I mean, we can do the type check, but then you're behind the type check. This would be if you did the as span, then you get to even bypass that amount of runtime reflection.
Right.
As for adding a member on SZ array, like you said that, and I felt like Jan Kodas would murder me. If I'm wrong, then sure, we could add it.
I mean, we've done it in the past, right? I would only do it when we believe there's a value and we don't regress the universe, right? But
I just feel that's one of those types that the runtime doesn't like new members being added on, because especially that arrays are, special in .NET. But I mean, yeah, if we can add a target member there that does better binding, then sure. Otherwise, an analyzer of, if you added .as_span to your to the quote unquote instance being passed, or that's the target of this method, then hey, look, now you're hitting span sequence equals instead of enumerable sequence equals, and that's better. Alternatively, actually, I think we could probably add enumerable.sequence equals of t with arrays. And so then if you hit t array comma t array, we could forward that one directly to span sequence equal. So that's a compile time decision and not a runtime decision. I don't think we'd introduce ambiguity with a target, so you would just get a recompile benefit, which is the same thing as adding it as a member on array, but instead we're adding it as a stronger typed overload on enumerable.
I mean, that's not a bad idea. I mean, that would.
It opens up a whole lot of floodgates, though. We've tried pretty hard to keep the public APIs for enumerable to be IEnumerable, and now if we start adding overloads that take arrays, we add overloads that take lists, we add overloads that take collections, we increase the surface area from 200 overloads to something much, much more than that. That's why Link has gone down the path of doing these type checks.
Fair enough.
It might be better if, one of the biggest problems with Link today is that we do have few overloads, but we also end up with overhead from checks because the JIT doesn't specialize reference types. And maybe that's something that we could talk with the JIT team about and investigate to see if there's something we could do to improve that handling, so that for maybe in an opt-in pattern, you could specialize for specific types where we know that it's performance-oriented.
Okay, so I have some notes here. I guess at this point, should we just mark it as needs more work, because we talked about a bunch of stuff that we could be doing in this case, and if I just mark it closed, then I think all of this stuff will disappear from our radar. So,
in other words, you're marking it as needs more work for someone to open new issues and then close it?
yeah, I mean, that might also be, I mean, yeah, we can either do that or we can just rename whatever we think the right action is for this issue, right? Whatever we think is better suited.
Right. Because I think that, Tanner, with the thinking about the general improvements of maybe changing something about how the JIT does generic methods with reference types, really is a very different and big concept. I think adding this analyzer, my feeling is no. I think the consensus feeling was no. But adding an analyzer that suggested writing as span seems workable, and then Steve seems to be against adding specialized entry points on enumerable because it's, in the words of Yes Minister, the thin end of the wedge.
I just think if we're going to do that, we need to do it, and that's a big deal.
Yeah.
I mean, I guess maybe I'm an outlier, but to me it seems okay to special case some array versions because array is meant to be a very low-level, core type, so that one wouldn't be bad. But I think everything that is more high-level, like all the interfaces or collection types, I think at that point it would be hard to argue that the type check is the expensive stuff, right? But for arrays, I could see a world where like the array is relatively small, so the type check is just making it more expensive or whatever. So I think if we do it targetedly for things where we know it's worthwhile performance-wise, I could live with that. But yeah, as a general principle, we should not add a lot of overloads on enumerable because it's already
right. But to take Steve's thin into the wedge, I mean, that's my words, but his concept, like with list, we added the members that allow you to get the spans from the list. So if we added one that took two list of T's, then or a list of T and an array, then both of those can be turned into spans and then call span sequence equals. And but I don't know that we're going to add, 4 overloads to address that.
No, we wouldn't. But I think like for list of T, is the type check really the thing that would kill you? I don't know. Maybe.
It's just it's one of those things of every extra if that's a special case path at the beginning of sequence equal slows down the average sequence equal. To make the thing that we think is a better special case faster. I mean, we do them because we think that they're worthwhile. It's just that's the cost. So.
Right. So these are the notes that I have. Is anything missing in here?
That there is room for one analyzer, which is 2 arrays going into enumerable sequence equal. It could suggest adding as span to the left member.
I see.
So that is an analyzer fixer option. You could have written more optimal code here.
I guess the other things at the bottom are just the other mitigations, whether we just make the code work. All right. So then I think that's it for today. I think I see you guys on Thursday, I believe.
Sounds right. I think we have 3 this week.
All right. Have a good one.
Thank you. Thank you.